Hey, page 556. Continuing the conversation about tangent ratios when the triangles are similar. When the side opposite the acute angle measures 90 minus x degrees, which by the way is the other acute angle, go back and look at page 555 video if you haven't yet, then we can write the algebraic expression representing the length of the side opposite the acute angle that measures 90 minus x in the same way we did for the other one because of the idea of scale factor. The triangles are similar in size, so there is a scale factor that takes one triangle and dilates it or reduces, enlarges, etc. to make that one triangle meet the other one. The way to calculate scale factor is to take the image and divide by the pre-image. And when you do that, in this case, we have an A constant value. I mean, it could have been any letter we wanted to, but why not A, first letter of the alphabet? And what I mentioned in the last video, I'm bringing forward to you now. You take L2, L sub 2. The little 2 is below the L, so like a submarine, L sub 2. A times L sub 2 is the length of the other triangle's corresponding side length. And we're going to use that ratio to write the tangents of both triangles. Remember, tangent is the idea of opposite over adjacent. So the tangent of an angle, the reference angle, is going to be the fraction of opposite to the adjacent side. And in the small triangle, the tangent for angle x means I can write it like this. Tangent of, I should say the same color, x degrees is gonna equal, and I need to go back to the small triangle and gather the opposite side divided by the adjacent side. I'm gonna acknowledge this. Opposite has been the side that we are consistently highlighting for me, for my videos, yellow. And the adjacent side is the orange line that we've been consistently highlighting, orange. So on the small triangle, that'd be L sub 1, L sub 1 is opposite, divided by L sub 2. L sub 1 divided by L sub 2. In the large triangle, we can also write that triangle's tangent ratio. And so in the large triangle, we have an opposite side and an adjacent side. And remember that that larger triangle, its sides were like some scalar multiple that multiplies L sub 1 times A to get A times L sub 1. And multiplies L sub 2 times A to get A times L sub 2 for the other triangle side lengths. So in the large triangle, they have the same angle of x, but now it's A times L sub 1 over A times L sub 2. That should look familiar though, because this is still opposite side and opposite side over adjacent side and adjacent side. And if you can take one fraction from the small triangle and write it equivalent to the fraction from the other triangle, you've written a proportion. And all that trigonometry is really the understanding that we're dealing with proportions. So we have our small triangles proportions, L sub 1 divided by L sub 2. And we have our large triangles proportions, A times L sub 1 divided by A times L sub 2. Because A, the scale factor, is the same number in the top and bottom of a fraction, we can reduce it. So then the A's end up reducing, leaving us, changing the color on purpose right now, L sub 1 over L sub 2. And that means these are actually all equivalent. This shows that the tangent ratio is going to be constant when a small triangle with angle x is compared to a larger triangle with the same angle x. Their tangent ratios are going to be the same. Explain how this proportion shows that the tangent ratio is constant for all right triangles with congruent reference angles. Well, A over A equals 1. So that part of the problem is going to cancel out. Which means the opposite to adjacent side ratios are equal. That's what tangent is. Tangent's opposite to adjacent. Listen, this has been a full conversation on page 556 about tangent ratios. Thank you for watching. Next up, we're going to talk about the concept of inverse tangent, because in mathematics, if you do something like an operation that changes a number, there has to be an opposite that undoes or reverses that operation. So stick around. Page 557 is next. I'm going to show you how to do the opposite of tangent, the thing that undoes what tangent tries to do to a number. Thanks for watching. I'll see you in the next episode.